So looking at number 1, this was a great pick by you guys because there's one on the test similar to number 1. All right, a pie is removed from an oven at 450 degrees. So time and do you have a variable preference for temperature?
Yes.
Big T? Do you want to do big T and little t?
Yes.
Okay. I'm fine with that. You just got to be careful if you're going to use T and T. So initially the pie is 450 degrees. Left to cool at a room temperature of 70. After 30 minutes, the pie's temperature is 200. How many minutes after being removed from the oven will the temperature of the pie be 100? Okay, this one doesn't give you the formula right here because it's on the reverse, but when you need it on the test, it will be there. The rate of change in temperature is equal to K times temperature minus temperature of the room. It's Newton's law of cooling, but we will give you that if you need it. Okay, so the rate of change is proportional to the difference. I've got two pieces of information. So let's separate the variables. Being always careful about the uppercase and lowercase t's. It's perfectly okay to do that. Just be careful. How about the left side? Do you know what that's going to be without using U substitution? Natural log of t minus 70. If you need to do a U substitution, and yes, it turns into natural log of t minus 70. And on the right side, what does the right-hand side become? Okay, be careful. There's a difference between the integral of k dk and the integral of k dt. The integral of k dk is k squared over 2. That's worried about k as the variable. This means t is the variable. So what's the antiderivative of k dt? kt. They both need a plus c. So when we first started, a lot of times people are like, well, what does that dk dt at the end matter? It's like, well, it tells you which variable we're integrating with respect to. So kt plus c. What next? Fishhook thing. E to the kt plus c equals t minus 70. So t equals 70 plus, oh yeah, I can move the c down, c e to the kt. Remember, that's a little bit of a trick. This is a different c than this c up here. So let's pause for a second here because I've got 5 letters in this problem. Is t a variable or a constant for this problem? Variable. T is changing. That's the temperature. C. Is C a variable or a constant for this problem? Constant. E. Is it a variable or a constant? Constant. It's a constant. Like E is always the same thing. We know what E is. K. Variable or constant? Constant. I don't know what it is, but it's a constant. T. Variable or constant? Variable. T is changing. So as time changes, temperature changes, and I need to figure out what C and K are. But they gave me 2 pieces of information, so hopefully that will be enough. So let's use the one with 0 in it first, because usually that makes things go away and makes life easier. E to the 0 is 1, so C is 380. I'm going to sort of box my answers in parts here. So got the formula, now I'm going to find the pieces. I know C. Alright, let's back up and use that other point. 30 minutes later, the temperature is 200. So a little bit more algebra involved on this one. Skipping algebra steps like crazy here. Subtract 70, divide by 380. What do you want to do next? How do I get k by itself? Natural log both sides. Some people phrase it as undoing the fish hook. Natural log of, I'm going to reduce that, save myself a little bit of work here. 13 over 38 equals 30k. Yeah, easy check. If you fish hook that, you'd get right back where you started with. E to the 30k equals 13 over 380. So k is natural log 13 over 38 all over 30. And so sort of the combination of all three of those things, I've sort of solved the problem. I haven't answered the question yet, but I've solved the problem. On the test is no calculator, so it doesn't go much further than this because you need a calculator to get much further. So you can leave all this, it sort of forces you into a safe stop on the test. And part of the reason is I won't have my calculators because SAT testing. Let's see, we're not done yet because I need to know the time when the temperature is 100. So, sort of my last entry on the chart. If the temperature is 100, solve for t. And even though I've got k written there, I know what it is. Like it's whatever this ugly number is, but I know what k is, so that's not a variable. Or it's not even an unknown constant. It's a known constant at this point. So 30 over 380 equals e to the kt. Natural log both sides. A little bit of reducing. So natural log of 3/38 over k. And I mean, that's a safe stop. Like you've defined what k is. So you could leave that and be done. Like there's my time. If you want to know what it is, you type it into the calculator. Now, I'm curious because I want to see if it makes sense with my, sort of with the rest of this problem. So I'm going to find out what it is. So let's find k first. I guess I could type it all in, but that would have a lot of parentheses. So natural log 13 over 38 divided by 30. That's K. So store that as K. Natural log 3 over 38 divided by K is 71.011. Let's see if that fits the pattern here. Oops, minutes. So after 30 minutes, it's cooled to 200 degrees. In another 40 minutes, it's cooled to 100 degrees. I don't know, that seems reasonable. It doesn't seem crazy. Right? If we'd have gotten something less than 30, we certainly would be concerned. If we got 5,000 minutes, you'd probably think that's not quite right. So I can't tell for sure by looking at it, but it at least sort of fits the pattern. So I feel good about that answer. Of course, I also feel good about that answer because it's at the bottom of the page, and it's the same thing as the answer key has. So number 2 is posted in a different video, and number 3 is similar to number 2. So hopefully you can make sense of those 3 problems.